Hi guys, good morning. Welcome back to a new video. Again, if this is the first time you're visiting this channel, so we discuss post-contest solutions of every problem after the contest and also daily problem intuition which comes on Leetcode. Cool. In this, we'll discuss very deeply everything by proof. We will see what is happening and what is the time complexity because that will play the major role in this problem. It simply says that we are given an array called as nums and an integer called as and values. Again, you'll be confused. So I'll refer and values like this and values. Cool. Of length n and m respectively. Now, the value of an array is equals to the last element of that specific array. So you will see that later on they will refer that please tell us the value of an array or basically add the value of an array. So value of an array is the last element of the array itself. Now, basic what I have to do is I have to decide the nums. I have to divide the nums, sorry, in m disjoint continuous subarrays such that the ith subarray, its bitwise and of the subarray is equal to the and value of the I. What I mean by that is I will be given some nums. I have to divide that again. This size is n, this size is m. The size of n here is 1, 2, 3, 4, 5, 5. The size of m here is 4. So I have to divide my this nums array into 4 continuous segments. I can say this, 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 this. Again, 4 segments, continuous segments. And then what I have to achieve is that for that specific segment, the and value should be equal to the that segment. Okay, so you can see this is the 0th segment and it is the 0th indexed and value and should same. Again, I will do an and of that specific segment and it should be same as the 0th index one. Okay, the first, then okay, next segment is first segment, so it should be same as the first indexed and value. Second segment is this one, so I will take the second and value. Third index is this one, I should take the third and value. So I have to take this. Again, there can be multiple ways how you can make a subarray or basically group some elements. And you remember the cost, basically you will see you have to return the minimum possible sum of the values of m subarrays. So each subarray, as you can see here, I have 4 subarrays. So each subarray will have a value. The value of a subarray is the last element of the subarray. So the value of the first subarray is 4, next one is 3, next one is 3, next one is 2. I will have to do the summation of them, and whosoever is giving me the minimum sum, that is going to be my answer. In this case, 12. If you look at the next example, you will see that we have to divide my this nums into 3 segments. So I can easily see I can divide my nums into this segment. The and will be 0. Then maybe this segment, the and will be 7. Sorry, and will be 7. And then the last segment and the and will be 5. And thus I can simply easily say that the cost or the value of this specific array is 7. This specific array is again 7 because of the last element, and this specific array is 5. So ideally the cost here you can see it is 14 plus 5, which is 19. But I can see my answer is 17 because I know that I have to return the minimum possible sum. It can be achieved when I would have taken the first subarray as up till 5 only, and the second subarray would have been here. So instead of giving a contribution of 7, I would have a contribution of 5 for the first subarray. And thus it would have given me a value or a summation of 17, which is the minimum summation possible. Now, do you have got the question? Great. Now let's see what you will do or what you end up doing. If you consider this as both the arrays, nums and values, what was happening? Again, every question I focus on one thing. Randomly jump to any index and then see what you wanted. Let's say I jump onto this index. So what I wanted was, okay, this index can be a part of any subarray. So let's say my subarray I was building up, and again, make sure you remember your aim. Maqsad nahi bolna hai. Your aim was that you have to take the and of that subarray. So I will be taking the and of the subarray, okay. And then if that and let's say done, or maybe we are doing the and, no matter what, I will be taking the and of that ith element in the existing and value whatsoever I have accumulated, and then I should be matching that with my jth value of my and values array. This is what I will keep on doing. So what is happening here, and what you should do? Ideally, you can just think of, okay, if I'm making my specific and subarray, If you remembered, in this case example itself, it's the reason I told you the example. In this example itself, what was happening? That you were building your and subarray, which means the first subarray you were building. You keep on doing the and. You had two options. Either you can stop right here, or you can continue, keep on doing the and maybe stop in future. Continue, keep on doing the and maybe stop in future. And you can also see that either you could have stopped at 5, or you can continue doing, maybe stop at 7, or maybe continue doing and stop at next 7. You had an option. Although the stopping condition you need to validate, because after stopping, the and value of this should be equal to your jth index and value. But for continuing, you can keep on continue. So you realized that you have two options. Again, it is the same way saying take, not take. But ideally, it is not specifically saying not take, because I cannot skip some element in take, not take, as in we are relating with the existing problem. We have take, not take, but we cannot say not take. We cannot skip some element. Why we cannot skip? Because it is a sub array, which says we have to take an element for sure, and it should be continuous subarrays. So ideally, we realize that we will have at a specific index, we will have two options. Either I can continue taking it, or I will stop right now. I will stop taking it. Okay, this will be stopped right here. Or maybe I can say I will stop maybe right here itself, and then from next onwards I will start afresh. Or I can say I can continue taking it. So I realized that I have two options. Either I can keep doing something, or I can stop right now. I can stop here right now, and I'll say from next onwards I will start afresh. So I realized I will have two options, and it seems like I have some indexes in I have some indexes in J, which means I will go on iterate on your nums, J will iterate on your and values, and then you also realize that you can have two possible things, which is kind of similar to take, not take, which is end now or keep on doing. Thus you realize that, bro, it seems like I can apply DP and stuff, and also I have my states with me. So states are I and J, but I will ask you, is your states I and J sufficient for you to let you know the answer? I'll say no. Why? Because if you remembered one thing, here what you were doing, okay, this was I, this was, and your J would have been pointing, which will give you that this specific and after and, it should match to your and value of J. So J also you need. But you also need one thing. What is the and of this specific portion? And to be more precise, that when you were at ith one, so you should be knowing what was the existing and value, so that you can just add the contribution of C. Again, maybe after adding the contribution, maybe you can stop it right here. After adding the contribution, maybe you will stop it right here, or you can keep on. Again, you can stop it right here, as you did here. When you added the contribution of C, you stopped right here, or maybe you add the contribution of C and you still kept on continuing. But you have to know what was the and value. So for that reason, if you had to know what is the and value, you realize, okay, I need to store the and value also. So I have to store I and J, I have to also store the and value. Now, and value of what? And value of nums of I. And nums of I, ideally in our case, is 1e5. Which means, see, and values and of a few numbers. And values and of a few numbers. Now, few numbers as in, my numbers can be value of 1e5. And let's say I have 1e4 numbers. So I can have 1e5 different and values. Makes sense. Logically, it makes sense that if I have value of nums of I as 1e5, so for sure, I can have 1e5 different and values. Okay. If that is the case, then your I, as you can see, it is 1e4, as you can see, will go to n. Your J, which is the and values array, it is maximum of 10. But your and value, which is the current and value which you were actually thinking, and you said by yourself that it will be 1e5. If that is the case, then 10 dish for 10, it will actually give you TLE. But there is something which has the and property. Like, there's a special thing. Everything is based on and. Can we use some and property? If you had not watched this video, in this I specifically depth, like, again, if you want to watch it, write 3108 by Aryan Mittal, Leetcode 3108 by Aryan Mittal, you get the video itself. If not, you can just write the problem name itself. on my channel, you will get the video, or you can write anything, you will get the video. In this, I specifically deep dived into and operation, which specifically mentioned that, again, I'll just give you a high level crux. It mentioned that as you keep on doing the AND operation, the value keeps on decreasing or remains same. It will never increase. So if I do an AND of two values and I got a C, if I do an AND with any value whatsoever, I will either, this value either will remain same, which means the value, this resultant value E will either remain C itself or will decrease. This E value will never ever increase. So this will never be possible. So you got to know, okay, AND value will always decrease. Now, why I'm telling you this? This is just for you to know that how will you prove how many number of distinct AND values can be there. Although the AND value itself, the value itself can be 1E5 or can be large, but how many different AND values, that defines our DP length, right? I am saying, okay, I can have 1E4 different I values from 0 to 1E4. I can have 10 different J values. Here I was saying earlier that my AND value itself can be maxed 1E5. But I am now about to prove that how many distinct number of AND values can be there. Right? Coming on back. So before we actually go on, and if you are actually surprised of how this AND value affects, so you can easily see that there is a proof that probability of 0 very highly and very strongly comes in when we keep on doing the AND. It, again, you can just simply read by yourself also, but I'll give a quick glance. So you will simply see that as the probability that the AND value reaches to 0, reaches to a, like, result in a 0, it is 1 minus 1 raised to power, like 1 minus 1 upon 2 raised to power 20 raised to power 20, which is actually approximately equal to 0.999, which is a very high value. How we achieved this? They simply said that, again, this was taken from one of the discuss pages. So it simply mentioned that with, okay, we have, where's this gone? Yeah, with 20 numbers, each bit has a 1/2 probability of being 0, right? Okay, half probability of being 0, half probability of being 1. With that case, I will have 1 upon 2 raised to power 1 upon 2 raised to power 20 probability of valid distribution where only 1 preserves the bit. So you see, okay, you will have 1 upon 2 raised to power 20. And then to get, okay, this is for 1. To get for 0, 1 minus 1 upon 2 raised to power 20. And then for all the 20 bits, Aryan, why 20 bits? Because if you remember, you have your nums of I as 1E5. Now, if you check 1E5, then I can represent my 1E5 by 18 bits at max, right? So 18 bits. Now, to be more precise, like as in to be more holistic, let's take it 20 bits. That seems a good number. 18 is a very bad number. Cool. So I will take 20 bits. So that's the reason you will simply see that how high it is the probability. Again, that is for the extra which who are curious for the proof and stuff, but we'll come on to the actual stuff, which means how many distinct values of AND we can have. And now my claim is that, again, if I go to my claim is the maximum number of distinct values of AND can be actually 18 only, which is directly representative of what is the maximum value of your number, which is 1E5. If you have 1E5, so maximum you can have 18 bits which are set, and thus I am saying the maximum number of distinct AND values in number can also be 18. How and why? You will simply see, if you initialize with the maximum number, which is the 18 bits itself, and you know that to change, again, I said that distinct values of AND. So you, to change, okay, right now the number of AND is this. To change it, or to basically get something else, you have to flip any of the bits here. If you flip any of the bits, which means you will make some bit 0. And the best part about AND is, as soon as you flip a bit to 0, there is no way you can flip it back to 1. With doing only AND operation, you cannot flip it back to 1. So if I have a corpus of 18 bits, I can try 18 times to keep on flipping bits. So I will have 18 distinct values and not more than that. Thus, we realized that the maximum of distinct values of our AND will be log of maximum element, which is in our case 1E5. And thus, if we go on, it will be I into J into log of 1E5, which is the current AND value. And thus, the same way for space. My answer is the same, no difference. So that is how you can simply get it. Now, if we go and look at the code, again, it is very simple and same way how we do it. Again, so far, if you have been liking it, it will be very, 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 very helpful if you can please smash the like, baby, and also comment down below what you learned from this video. because the channel is dying recently, even after publishing daily, and also for every contest also, and daily. So yeah, it will be very helpful. Now coming on back, if you can share it, that would be lovely. Now, okay, coming on back, we will firstly have to go and make our DP. Now, for DP state, we know that N and M are fixed, because you know that N is fixed, the number of sizes of the nums, M is also fixed at max 10. But your distinct values, you cannot decide an array size. Although Aryan, you said, array size is 18. Yeah, true. But this says you will hash the index, you will hash the j index, but then this way you will have to hash the and value. I told you, and value can be large, but distinct and values will be less. That's the reason I have to take an unordered map, because I know the distinct, again, this int will handle the large values also. It can be 1e5, 1e4, 1018, anything. But that distinct values can be just 18. So I will be sorted in this case. That's the reason I have to take an unordered map, and I cannot define a fixed array here itself. Now I will simply call my helper function, which will simply, again, these are constant. I will go and give my I index, which is pointing to your nums of I. I will give my j index, which is pointing to the and values, and then I will give you a initial and value. I will give you an initial and value, and as you have remembered, and value keep on decreasing. So this says, like, this is representing that I will have 20 bits all with marked as 1. See, 1 left shift 20 is 1 and 20 zeros. Minus 1 says that I will do a minus 1, which means this will go away, this will become a 0, and all of these will actually become a 1. So now I have got 20 ones. So this is 20 ones I have got, although 18 will also work here, but 20 looks some more clean, so that's it. I put it. In the very beginning, you defined the 20 bits all as 1. And that, again, for and by default value is initialized to all ones. And that I also taught in this video also, if you have remembered. Where is this gone? Yeah, I also taught in this video also that how you define or how you initialize your and values. Now, coming on back, we'll go on to our helper function, which is a DP value. In that DP value, I'll simply have a few things, very normal, that base case we'll go on to later. The actual recursive case, which is simply checking I, j, and your current and value. Again, if you remember, this is your I, this is your j, and this is your current and value. If this is found in the DP, then simply return that. That's an obvious use case of DP. Let's come to the main recursive case. The recursive case mentioned us that, if you remembered, we had two options. Either I can include this or I can exclude this. If I make you recall, then if you remember, either I can include this element, or I will say, bro, keep on moving. And again, inclusion of this element, as in closing this bracket, is only and only possible provided this portion and value result in and value of nums of j. Only then closing is possible. But okay, if I say keep on going, you can keep on going anyway. Even if it is possible to close or not, you can still keep on going. And that we proved in by using this example. Even if it is possible to close or not, still you kept on trying for multiple different values because you want minimum sum. So that's a reason. In this case, if you see that I will have, again, if things are excluded, which means it is not necessary to close. So in this sum if included, which means I have included this, I will close it right now. So firstly I initialize the maximum value just for safe side. Again, Aryan, how you know this is the maximum value? Again, if you go back and see what you wanted, you wanted your sum to be minimum. If you go back and check the constraints, what is your sum? What can be your sum? You know that you have 10. Again, you have an array of a size 1e4, right? And you told me the sum will have the last element of the subarray. I can have at max 10 subarrays. Last element taking at max itself, at max value of a last element can be 1e5. So I told, okay, maximum sum can be 1e6. So any value more than 1e6 you can take. So I will come back and I can put in here also 1e6 plus 1. It will also work. But to be on safe side, I take holistic numbers, which is 1e7. Now, if I come back, I initialize the high value, which is 1e7. Now, I told you that included, which means close it right now. It is only and only possible if the and value matches, which means current and whatsoever I would have been getting, and I know that I have to take this element and close it right now. So I do a current and the current number which at the ith index, if it is equal to the and value of the j, only then I can close it right now. And when I say I close it, which means that this nums of I, I'm closing at this ith index itself. So I have to add this number in my sum contribution. So I'll add my nums of j in my sum itself, and I can simply ask my recursion for a fresh start, for a fresh start from I plus 1. And in the same way, I have consumed my j also. So fresh start from j plus 1 also. So I will start from I plus 1, j plus 1, and also it's a fresh start. So your and default and value so also have a fresh start. That will also have a fresh start. And the same way, even if you want to close it at that location or not, which means include it at that location or not, still you will try to move on. This is excluding, which means moving on. Again, I named it such that, okay, it's okay for you to understand inclusion exclusion as in take not take, okay not okay, like this, which means it will still be keeping moving on. And as I said, it will move on for means for sure it will not close at that point. If it is moving on, for sure I will, the current and whatsoever I have, I will add the contribution of nums of I, and then again I will have to move to next index I, but my j will still be there because I have to still compare with the current and j, current values of j. This will do, this I will do no matter if it is matches or not matches, still I will do it. That is all with the example number 2. And ultimately you want the minimum value, so ultimately get the minimum value of both of them and return that as an answer and store that for your DB to use it. Ultimately, in the very end, you can check if your answer is still -1. There was no possibility to get your answer of m continuous subarrays. Else give answer as -1. And you saw the time complexity of this will be 1e5 into 10 into 20 in the worst case. And that's how you solve it. Cool. Bye-bye. Take care. It was not hard, but the only thing is, if you had watched our previous video, it would have been a much easier experience. Again, proving also, remember this fact that how many, again, make sure the start point here is that you only are applying the AND operation. Only then you will have distinct log of maximum element number of distinct values. Bye-bye. Take care. Again, you can go and check out the comment section. Top comment, as in like the comment. If you want, if you are in college, then I highly recommend go and check out the comment section. First comment, which I would be putting for sure. Maybe first or maybe not, but yeah, check it out. Bye.